What kind of naming system is that?
And then the most famous alcohol is ethyl alcohol, which by IUPAC is ethanol. Because it's so common and even sold as a beverage, it's just called alcohol. So even for chemists, if you say alcohol, they know that you mean uniquely ethanol. Ethanol, though, is one of the most confusing alcohols. Biologists in particular use ethanol often without understanding the differences between alcohol. There is 95% alcohol and absolute alcohol.
No, I'm gonna get you good on
Not the
this
brand
test.
name absolute, but called absolute alcohol is 100% ethanol. That's very different from 95% ethanol. And the story is that 95% ethanol is actually what is produced commercially by the fermentation of grain. We get ethanol basically from the fermentation of grain. And you know a lot of it is added to gasoline now. But it's also a feedstock for the chemical industry. When you ferment corn, for instance, it's done in a large vat which contains mostly water and corn, and the whole thing ferments, and the bacteria produce ethanol. And then you have to distill the ethanol out of the corn mash. When you do that, the lowest boiling thing boils first. You know that from organic lab. The lowest boiling thing in there is not ethanol. It's what we call a binary azeotrope of water and ethanol. Azeotropes are mixtures of 2 or 3 things. There are ternary azeotropes too, that boil at a constant temperature as if they were a pure substance. Ethanol, 95% ethanol and 5% water is a binary azeotrope that boils lower than the boiling point of pure ethanol. So when you distill that corn mash, what comes out is 95% ethanol mixed with 5% water. Nature always does the easiest thing first. And there's so much water there that you can't distill anything but 95% ethanol. Now, if you buy absolute alcohol, what you're buying is 95% that has had the water chemically removed. That is a very expensive process, and absolute alcohol is quite expensive, much more so than 95% alcohol. And my point is that you can't substitute one for the other. The 5% water and 95% ethanol makes that solution much, much more polar than absolute ethanol. So what happens a lot, not just with biologists, happens with chemists too, is the procedure calls for 20 mils recrystallizing, let's say, from 20 mils of 95% ethanol, and instead they use absolute alcohol, thinking ethanol is ethanol, and it doesn't work. The polarity is very, very different, so you have to notice what you're using. The second thing you have to notice is whether it's denatured or not. Because of the federal tax on, and state taxes on alcohol as a beverage, to use it in the lab, you either have to have a license and keep track of all that you use and report that to the government, or you have to buy undrinkable ethanol that has been adulterated with what's called a denaturant. One of them is aviation fuel, for instance. They add about 5% aviation fuel, either to 95% or absolute. So you don't pay any tax on it, and you don't have to file any paperwork. So most of the alcohol that you see is denatured. Now that denaturant is a factor. Is it aviation fuel, or is it methanol? Sometimes they denature with 5% methanol. Sometimes they denature with methyl ethyl ketone. There are at least least 10 different denatured formulas for alcohol. And as a scientist, you're supposed to look at that and say, okay, I know what I'm dealing with. Is this denaturant going to be a problem for me in terms of how I'm going to use it? So you have to make that assessment and use the right grade. There's histological grade ethanol, for instance, that has particular denaturants in it for that type of work. Okay, and of course the whole business around ethanol is that within a very limited range your body can metabolize ethanol. But as you know, tragically, in all too many cases, if you exceed that, you can die very quickly. The point is that while your body can metabolize it, the threshold is a very hard line. It's a red line, and if you cross it, everything goes wrong very, very quickly. It's a rare chemical that can cross the blood-brain barrier, and that's where it does all the damage. It shuts down your respiratory system from the brain. Most chemicals, most organic chemicals cannot penetrate the blood-brain barrier. And that's a big problem in neurology, where you try to treat patients with drugs. There are very, very few drugs that can get at your brain. Your brain is extremely well protected, but not from alcohol. Okay, so ethanol, alcohol, ethyl alcohol, grain alcohol, all the same thing. The boiling point for ethanol is higher than methanol. It's very consistent. As the alcohol gets bigger, the boiling point goes up. But also, alcohols in general have humongous boiling points. I compared methanol to methane. The molecular mass and size is not terribly different. Methanol boils around 60 degrees. Methane is a gas down to about minus 40. So big difference. The polarity and the hydrogen bonding really raise the boiling point. And it just proceeds from there. The only other one that's really common is the 3-carbon alcohol, propanol, P-R-O-P-A-N-O-L. But here you get the issue, when you get the 3 carbons, where is the alcohol group? In propanol, it's on carbon number 1, or propyl alcohol. The one on the right is commonly called isopropyl alcohol. But by IUPAC, this is easy for you. You know how to do this. 1 propanol and 2 propanol. You have to say where, just like 1 chloropropane, 2 chloropropane, you indicate where the OH group is. Okay, well, we're just about out of time. That gets you started on the alcohols, get to the study guide and the book, and just start following through that chapter. But keep your eye on the study guide. Focus on that.